Welcome to this class, the distributed application developments. I'm going to ask you what you feel from the title and what do you expect a little later. This is the first time really offered in this computer science master's program. Anybody checked out the syllabus and have you had chance reading the syllabus already? If you did, then it requires a lot of things. Systems also very various. They need to talk to each other. I don't think any college, any universities has equipped all such facilities to enable or emulate all the functionalities that are required for distributed applications. So I designed this that we can do from cloud computing, cloud server. We cannot ignore the cloud server these days, so we should include it. And the other endpoint is IoT, so that I included also Raspberry Pi. I'm not sure anybody had the experience of a Raspberry Pi, but I ordered the Raspberry Pi, so each one of you can get this Raspberry Pi. In this way, Zoom classroom may not be good. I cannot show, although you can see what I now show to you. If I show camera, then I cannot show to you the terminal, vice versa. But if you come here in person, then you can see it all simultaneously. But anyway, but because of this classroom doesn't support our requirements, from time to time, as I explained on the syllabus, you guys need to work at home. I can help you at home also, mainly because router that we have to use if we meet in class, I mean in classrooms, universities, then we have to use university facilities, router. University router is tightly maintained securely. Originally, we have another classroom here, Manhattan, 425, that was designated to computer science and cybersecurity program. We built the internal local routers, all such things. If we use that, then we can use that router that separately from the college. That's what we designed, but the college didn't allow you. Colleges, yeah, they assigned that to some other program. I do not know. I asked what program much more important than ours. She said she didn't let me know. But anyway, so this will be given to you. You can keep it permanently. I'll explain this a little later. And also your laptop. So 3 players play together. Okay, so cloud, I'll help you to set up your own. Each one will have on your own cloud servers from Google. Google Cloud, initially free. I don't think at any point throughout this class you increase the transactions to the points they start calculating your usages, and therefore they will charge you. So they are so generous to a certain point of transactions and usages, resource usages, they don't charge you. So far, I've never been charged. So don't worry about. Even if they charge you, I think certain units, they charge $0.002, something like that. Okay, I don't know what that unit is, but I've never been charged. Sometimes when I experiments and practice some of the concepts that I need to do, if I have a chance, then I will let you know. I had the real practical project successfully done. So lots of transactions between cloud server and Raspberry Pi. And also while I was debugging my program, big transactions. So I was testing what's the point that they started charging. They never charged so far. So you guys will be okay. And this is our department requested this, the department, so that we can, fortunately we are allowed to purchase this. So I want you to go to the department and check out this for your own purpose. Initially purpose for this class. After this class, you can use. You know the department at Dobbsbury. If you never stopped by, you guys do not have class at Dobbsbury at all? Or you can talk to, I will link you all of you guys to the department secretary so you can communicate. Or you can ask her to ship this to your home address if you do not want to go to Dobbsbury. Before we start this, let's introduce. Yeah, all 3 students registered. Only 3 came to this class in person. Probably this is recording. I think it is being recorded. Let's see. How can I see? Yeah, it is being recorded. Okay. So we're okay. Okay. What is your name?
Benita.
Oh, Benita.
Yeah.
I realized that you never logged in
Yeah,
the Blackboard.
yesterday itself.
Oh, I see. So you know how to get to the Blackboard, where you can see our syllabus and course materials. By the way, class notes, I modified updated a little bit. If you checked out last night, that is one version older, where there is no homework assignments. I placed the homework assignments, first homework assignments, in the new lecture note. If you do not mind, Vanilla, would you be able to start introduce yourself first?
Yeah, I'm Benita. I'm from India. I'm here last year. I've completed my 2 semesters in Mercy University.
Which one?
I have completed my 2 semesters in Mercy University.
Oh, this is your
Third.
first university?
Yeah.
Not transferring from others. Okay.
No, this is my first semester.
By the way, what is your background, technical background?
I'm from electronics.
Oh, great. Then you're familiar with
Yeah,
this,
yes.
microcontrollers. Okay, what about the coding?
I'm learning right now.
Learning.
Not sure that I'm.
If you knew any, what language?
Actually, I'm just taking the course in AWS, so cloud computing.
What languages?
Oh,
Coding
Java.
language? Java, okay. All right, I think Malika Shah, right?
Okay, so I'm from Pakistan and I did my bachelor's in software engineering, so I have the technical background. I know some of the languages. I have like 6 years of experience, 2 years as a software engineer, and then afterwards I transitioned to project management. I've done 3 certifications and this is my second semester.
At Mercy, I see.
Yeah, at Mercy.
So you guys already know Python, right?
Yeah.
You took 505?
Yeah.
Object-oriented?
Yeah, we
We
had
did Java.
Java.
Oh, you used Java?
Yeah.
Yes.
At the end, our professor did a little bit of Python,
Mhm.
but it was just
Who
at the end.
taught?
Um,
Dr. Wang?
Professor Wang?
Wang?
Yeah.
Java is good, but
Oh,
yeah,
Python.
I was the first generation of Java in 1995. I took the certificate from Sun Microsystems. Sun Microsystems, the name of that company disappeared, right? You guys do not know. It was acquired by Oracle, but Sun Microsystems was the company that developed Java in 1995. So I took that course downtown in 1995
When I was born.
when you were born.
Yeah.
Okay. So I like the Java. I programmed the Java for about 20 years, and I switched it to Python. Programming, formal language-wise, Java is real programming language. Python is like a toy, unstable, unstable in theory. So they migrate their language a little bit, but expandability of language and applicability of language is really, really paramount. There is no end at all if you do Python. Java, computer scientist, you should know Java anyway. So you guys in is it track or you have two tracks, right?
Yes.
Data science and
Software
software
development.
developments. Okay. So your major was software
Software
developments.
Yeah.
So language that you used in Pakistan,
Yeah.
most likely.
PHP mostly, and
PHP?
then switched to WordPress, which is the open source.
Oh, PHP. Wow, strange. Anyway, we use PHP here for middleware from cloud server. If cloud server needs to talk to any of your laptop or your Raspberry Pi, then middleware is needed. I like PHP language. I developed a lot the middleware in PHP, so I chose PHP. But PHP is not the only language that you can use to develop middleware. But at least in this class, I would like to use PHP. Okay. Sometimes we can use Python, the middleware, but yeah. But because I have more experience in PHP, so I'm using PHP for this class. And for local language that we use on your laptop and sometimes IoT microcontroller, then we use Python. Okay, Martina?
Yes. My name is Martyna. I'm from Poland. I did finance and accounting for my bachelor's. Now I'm doing data science track and taking this class as an elective. I learned C++. That's the language I feel the strongest in.
Oh, okay. Then I think you'll be okay. If you know C++,
I want to get into.
although you're from non-tech
I-
background,
I
you'll
took,
be okay.
Community college classes, so that's where I learned C++.
Okay. All right. All other students who are currently online, we may be able to listen about your story later when we have a chance. Okay, let's take a look at the syllabus first. I'm John Yoon. This is my phone number. Oh, it's not stable, the monitor. I didn't notice. but it'll be recorded stable because my laptop. I'm now capturing a laptop screen, so my recording will be okay. Okay, but anyway, so my office hours. If you want to, you can for any time slots that you want to make. Pre-appointment is appreciated. Okay, for example, I allocated Wednesday for this. If you come afternoon of Wednesday, it'll be okay. If you come here in person, and also if we plan the two meet Manhattan classrooms, then we can meet. We can chat at any time, so it'll be okay. On Mondays, either Manhattan or Dobbsbury. So if one student wants to meet at Dobbsbury, then of course I cannot be here Manhattan. So one or the other. Therefore, if you want to meet me at Dobbsbury, then you need to make an appointment with me so that I move immediately after Monday's class to go to Dobbsbury or stay here. Glad. Wow.
Hi, Professor.
You are with me? Okay. Title, right?
Yes.
Title.
Hi.
Are you computer science or cyber security?
Computer science.
You're computer science? You were with me, right?
Yeah, I was with you at the mobile development class.
Oh, was it? Oh, okay. All right. You came here right time.
Thank you.
Each student wants to introduce.
Okay.
So now your time.
Okay, so Dr. Lagbo, my computer science, software development, so concentration last semester. So this is my second last course that I'm taking.
Oh, okay.
So yeah, I was in Brooklyn College before.
All other students said where they are from. Where are you from?
I'm from Bangladesh.
Oh, you're from Bangladesh.
Yeah.
So Bangladesh, Poland, Pakistan, and India.
Nice.
Because all many of the neighbor countries, right?
Yeah.
Okay.
So I was in Brooklyn College before. I transferred my credit from there, and I also had my bachelor's in computer science from WI. Before that, I had my associate from my community college in Virginia. I worked for General Motors for 1 year. I worked for different companies over the time when I got to work. Yeah, that's pretty
Are you
much
now
it.
international students or
Yeah.
domestic here?
International.
Still international students? So everyone international students right now? Okay. Okay. This is a graduate level course. Literally distributed application development. So we're going to focus on design, implementation, and management of applications. So we use for distributed computing. This may be a new term to you guys. Microservice architecture. One of the implementation most efficiently so far of this microservice architecture is Netflix. Netflix is best, so-called best implementation of distributed application developments. So we're going to look at Netflix. If it's not Netflix, then for example, Facebook, that is also one of those. And Google search engine, that's another things. Lots of the products from big tech are now part of microservices architecture. So we're going to use that. For this microservice architecture, cloud computing needs to be involved because the audience, subscriber, clients of that microservice architecture is worldwide. So it should be available all the time, everywhere. So they set up cloud computing. So we're going to set up cloud computing as well. All details I want you to read as we learn this class, you may be able to see what it is. But I'm going to point out something that is critical to you. Meeting, Wednesday, 11:42 to 20. Officially and originally assigned to 334. Right now we are there. And what that means is that we have lots of limitations. Almost impossible for certain topics. So, the resolution from this about this situation, we are going to meet. We may not meet. But I'm going to record my lecture and post it so that you can see, you can follow that video recordings from home. Mainly because router that we are using, the router built in university is okay if the network package is going out and coming in. It's not okay from there to another facilities. That is prohibited. So if you want to communicate with the cloud server, that is okay. But as I said, we have here IoT microcontroller. Then this guy needs to be playing as another server, but this guy does not have permanent IP address. If you guys can buy permanent IP address, each one of you, then we can do that. But to get the permanent IP address, then you need to pay, I think, at least $1,000 per month. I don't want you to pay. I've never paid in my life. So what we do is if we control router, then we know router has temporary IP that are assigned to this, and our laptop has also temporary IPs. So by knowing this IP, your laptop can communicate with that. That is possible if you guys have your home router. Okay, I assume each one of you has your home router. Do you have your home router?
I do this.
Yeah, then you can do it. But we cannot do that here. These classrooms. 425, there is we originally built that classroom for computer science and cybersecurity. Remember that we met?
Right.
Yeah, but it was occupied by the universities, some other programs, so we cannot use it. I planned that from the beginning of, right after the spring semester, but they ask questions. Why do we need that classroom? I explained this and that and that. After that, they didn't change my request. Therefore, resolution is, for the first few classes we meet here. But I'll let you know at certain points that from these points we cannot meet, so that you guys stay home and follow my recordings. There is no textbook, only lecture notes. There is no textbooks available in the world. This is very important, the format of this class, courses. Particularly hands-on labs. Each student must purchase Google Cloud virtual machine. As I explained, because of the low volume of the usages of that virtual machines, even if you registered it, they don't charge you. From my experience, I've never been charged. I don't think you are going to use more transactions as I have used in my experience for the past 1 year. So hopefully you guys do not have to pay. And on that Google Cloud Virtual Machine, what we want to do is we want to set up Apache, PHP, and database. Okay, 3 things needs to be installed and configured and start up serving. And then PHP code is needed. So I am going to give you a small code of PHP. As you wish, you can expand more and more. Those who do not know PHP, if you have a concept of coding, you may expand it from the backbone of my code, PHP code. You can start from there. So you guys will be okay. So what PHP can do at the cloud server is, that is for middleware. What it does is that literally the PHP program sits between back-end database and whatever the client that cloud server needs to solve. So client will be your laptop, client will be anywhere from the web request, client will be microcontroller, Raspberry Pi. That is another server that we are going to set up. That is a tiny server there. Python coding and web service. The coding environment, 2 things. Paizo. I want you to, I don't think anybody used Paizo before, but this is a lightweight of IDE, integrated development environment, right? So I'm going to guide you how you can install that. That is handy. So when I do Python, I always use Paizo. Or sometimes we use Google Colab. That is a web-based, so you do not need to install. Google Colab, very similar to Jupyter. You know Jupyter, some Python coder or developers, they use Jupyter. Same thing, the Jupyter. But this is Google Colab is web-based. From Google Colab, if you want to talk to some other programs like local MySQL, if you want to communicate with your local MySQL on your laptop from Google Cloud. Google Cloud is not your local. Your database is your local. How can they communicate? All those things needs to be understood and implemented. For that, we are going to use ngrocks. We'll do that later, and more and more. Okay. So this class hands-on lab requires various different kinds of tools, platforms, other languages to develop. If you guys have a MacBook, if you are good at Linux, you will be okay, no problem at all. So Linux is a must that you need to know. Windows, another addition. This Raspberry Pi, the Raspberry Pi, the operating systems is they call that Raspberry Pi operating systems, but that is a Linux. So if you know Linux, you'll be okay. Now, raise your hand if you never use the Linux at all. You guys know Linux? You don't know. What about PowerShell on the Windows?
Yeah, I know.
PowerShell?
Yeah.
Some of the languages similar, almost similar. What about used?
Just use Linux.
You use the Linux, you'll be okay, yeah. So electronics. Okay, so you will receive this so-called Kana kit. I chose this because unless otherwise you guys use one piece separately, all of a sudden you guys, I do not have that, I do not have this, how can I buy that? So I ordered this by the department budget. So I wanted to pick up one from the department secretary. So when you open this, I want to explain this. We are not going to use any of the pins that displays here. But you guys need to keep this just in case. If you want to do for electronics, then if you want to control, for example, any devices. If you want to control nuclear plant, for example, you can do that. If you want to control some of the electronic, the one that I used was the door lock. Okay, so if you go to hotels, then these days you can open the hotel door if they allow you to. Then some of the apps on your cell phones, right? But how do they communicate? So wirelessly, right? So that door lock inside, there's some of the microcontrollers. But most of the door locks, they have is a PC board. The computing power already printed, and then circuit board was embedded in the door locks. That door lock has some of the communication capabilities as well. Therefore, they can communicate this. In order to communicate, in order to lock and unlock and to rotate some of the motors within the door locks, then we need to configure some of the wirings and codings. Therefore, your Raspberry Pi can communicate that. And if you open this kit, then you may be able to see first of all, cables. This is a power supply, and then 128 gigabyte of the SD card. So this SD card needs to be configured with the Raspberry Pi operating systems. I will let you know how you could do this. And this is the case of that Raspberry Pi. And this is the Raspberry Pi, actually. So if you open this Raspberry Pi, this is a recent Raspberry Pi. Raspberry Pi 5. 5 is newly announced. What was the version that you used when you were in India? 3?
Yeah,
Two.
just 3.
3, right. Not long ago, right?
Yes,
Maybe
just
3 years or
2
2
years
years ago. 3. Now is 5. Okay. It's very expensive. It has a memory, very strong processor, ARM processor. Raspberry Pi was built in UK, United Kingdom. Another reason is if you purchase this, there is another made in China products. So I do not want you to use that for communication wise.
Not secured.
Hmm?
Not secured.
Thank you. You read my mind. Okay. But anyway, so this is very, very powerful. Okay. You can find this from there, and there is another USB the adapter. You can build your operating systems, Linux operating systems, or more specifically Raspberry OS from your laptop first. So you need to plug this SD card into this. This is the USB card. and then you plug into your USB, your laptop, and then you need to build the operating systems. Once you have done that, then you need to unplug this SD card and plug into your Raspberry Pi. If you look at the bottom of this, then this one side, there's an SD card slot. So you need to plug that SD card. And then we have a power outlets. So you need to connect the power here. And this two cables is HDMI cables. So you can display, because we have two HDMI cables. You can display one to your laptop, one to another. You can do that. Okay, so those are things that you can obtain when you pick up this. Okay. So I will connect all the students in this class with the department secretary. So you guys need to communicate with the department secretary, Maria, and you can set up any way convenient to you to pick up that kit.
Sir, when we will need that kit? When?
Yeah, one.
Like next week already, or?
Already in my office, so secretary can
Yeah,
allow
but
you to.
when we will need
Oh,
it?
I really need a few weeks later, not
Okay.
immediately.
Thank you.
Yeah, we're going to use. We need to first set up a cloud server, maybe not next week, but maybe third weeks. So we will do that gradually, adding more capabilities into our lab. Assignment. We will have quite a few assignments. Assignment is will be explained when I explain the schedules. The requirements of this class is a project, individual project. Project is only the requirements. Project and homeworks, no exam. Your project needs to use cloud server, Raspberry Pi, and your laptop. 3 of those needs to be interoperated. So you need to think some scenario which can share the data, some data from the cloud server, some data from your Raspberry Pi, some data from your laptop. So data needs to be combined or partitioned, whichever, according to your scenario. So data sharing, data communication needs to be demonstrated. That is basically the key point of your project. You need to build something for that. Don't try to make something big. Of course, it's not possible, right? Something smaller ones, but fully demonstrate. Data can be shared among those 3. Client is your laptop, okay? You are the client. And we have 2 servers. One server in cloud, another server, your Raspberry Pi, okay? That is the things. The outcome of the project needs to be written. So project report is should be submitted. And also your demo, project demo is required. Altogether, therefore, it'll be the portion of your project requirements. Evaluation, homework assignments, 55%, project 40%, participation 5%. Over 95%, you will receive A. According to this table, you may be able to see what it is. And all others university policies, I want you to read it carefully. And this is course schedule. So today, introductions. From next week, we'll look at distributed computing models. You will have homework assignments today. So if you see here assignments for each week, so we probably have about 10 homework assignments. Homework assignments is simple. The one that I do here, you need to do on your own and submit it. I want you to practice the way that I do here. Okay? Simple. So everything will be recorded, so you can follow the recording and redo it on your own at your side and then submit. There's similar things that we did in,
Yes, yes.
yeah, yeah,
Pretty much.
yeah. Just practice it on your own, okay? Otherwise, you watch it, and I'm the only player. And if this semester is over, then you don't get any. So I want you to do really the way that I show to you. According to this schedule, we are going to follow. Any question about this syllabus? Okay. So you can find out this syllabus from Google. Facebook. I'm sorry, Google. So this is. I'm not sure why they said. I already on the syllabus page. Let's see if I do course syllabus. I have syllabus here, right?
Yes.
All right. Course material. There is the first class notes. So each time, this is the way that you can see on Blackboard, the course material. Then I try to put the timestamps so that which class materials covered which date. Okay. So for today's lecture, I have only one item here, lecture notes, but will be more. That will be homework assignments. So you may be able to see September the 4th, 2024, homework 1. Then you can click on that. Then you follow that homeworks, okay? So right now, there's no homeworks that I put here. I'll show to you how I make homework assignments. So assignments here. Then I will do homework 1. If you see the class notes, then on the last slide, then there is a homework assignments 1. So I will, this is what I meant. And then due date for that, as I said, that'll be the September 10th. The homeworks, your submission needs to be complied with the requirements that I posted. For example, in this first homework assignments, I ask you to submit Python files. Then it's Python, if it is Python files, the file extension should be .py. I want you to submit .py files. Those who do not know yet, bear with me. I'll let you know how you can get that in a minute. So that is that. Deadline is the midnight of that. You will have a 1 week. This is a very simple homework assignments. I want to make sure you guys know a little bit of Python. Okay. If you do not know Python, practice a little bit. You may get that. Okay. This is what I can do. Submits. And when I see this, you will have here class notes and homework assignments 1, right? So you won't miss. Okay, and if there will be another ones because I'm now recording my lecture, so that will be Oh, by the way, I need to do this. I need to put here not just homework 1. I want to put here September the 4th, 24 homework. Yeah, so that you guys see the timestamps. Another one is recordings. For the same timestamps, for this example, you will see 3 items. So usually you guys see 3 items: class notes, homeworks, sometimes, and then recordings. What else that I need to explain that to you? You can get your grade from your, I think, a grade book. Your menu, left side menu, may not be the same as mine. This is the instructors, so, but similar to this. Okay, this is that. And then this is first lecture. I am going to make it bigger. Okay. Why distributed application development is needed? We need to start from there. Why? Why distributed application development is needed? Because the world is so dynamic. World is expanding, exploding, right? Exploding. It's bigger and bigger, or sometimes smaller and smaller, and everywhere. So scalability is one issue. Once something is built, it lasts 10 years, then we may not need the distributed application developments. One small coding maybe work. But these days, you may be able to see some product from big tech. It's so dynamic, and client and users of that products is really, really massive, right? Facebook, how many users simultaneously? Millions of users, right? Simultaneously. Google, YouTube, or Netflix. Hey, what happened to you?
Oh, I was trying to find the room. Yeah.
Trying to find what?
The rooms.
Oh.
I didn't make note of it before I left the house. Yeah.
Oh, it took you 1 hour to find this. You must be Nam Hoang?
Yes, sir.
Nam Hoang? Nice to meet you.
Nice to meet you too.
Can you introduce yourself first? First of
all,
all, where are you from?
hi. I'm Nam. I'm from Vietnam.
Oh, you're from Vietnam,
Yes.
okay.
I actually took class with all 3 of them last semester with Dr. Van Navarre.
Oh, okay.
Martina.
What city?
Oh, I'm from Hanoi.
Hanoi.
Yeah.
Okay.
So, hi, I haven't met you.
Hey,
Nice to meet you. I'm sorry? Yeah. Nice to meet you.
Okay. What is your technical background?
I was a IT major in my bachelor degree, and I worked in cybersecurity for a few years, and yeah, now I'm going for computer science.
What programming languages do you know, or are you familiar with?
Mainly JavaScript.
JavaScript.
Yes.
Oh, so not formal language yet.
Yeah. Well, we did took Java last semester.
Last
so
semester.
That's also that.
So you may be okay with the PHP then.
Yeah. Oh yeah.
Yeah. Okay. So the language that we frequently use in this class is Python. So if you know Java, then Python is like a baby, right? So you'll be okay. So scalability is one of the major reasons that we need to do distributed application developments. Please don't be bothered by this screen. This classroom's screen is not really, that's not what I'm doing. It's not stable. All right. This class notes slides available from your Blackboard. So you may display that Blackboard class notes if you like. Fault tolerance is another reason that we need to do distributed developments. For example, if our system runs distributed and serviced from various different locations, then even if one location is shut down, we can access the same content from other location, right? So that should be transparent. What that means is that we should not know which server serves the content that I am currently subscribing. As far as I know, as far as I receive content, I'll be okay, right? The server side, as far as your client is okay, your server is okay, right? You don't need to make one server. You can make multiple other servers. There needs to be all simultaneously dealing with the same data. Technically, not really, but almost. Fault tolerance. So today's application needs to be resilient to any type of failures. So you need to get the services 24/7. Resolution utilization. Today's application needs to access remote data efficiently in response to request. Resource needs to be utilized. That's what I want, right? We all together may be able to realize when we build our cloud server from Google, always available. Whatever the services that you build from your Google cloud server, your client needs to be also fully enjoy the way that you enjoy with Google. Your server needs to be serviceable and transparent and utilized and flexible and modularity. Today's applications are on microservice architecture, as I explained that earlier. Almost all the big tech products now based on microservices architecture. You name it. Google services, Facebook, Netflix. Why Netflix is technically utmost advanced? Because that deals with multimedia. You guys, anybody subscribing Netflix?
Yeah.
You waste a lot of your time on Netflix. Any complaint technically from Netflix services so far?
No.
Anything so slow or anything messed up? If you guys feel good, then who works behind? Netflix, high-tech technicians are working on very hard. So their services is really, really good. So microservices architecture, what that means is that, I explained already, but all different kinds of services, applications, platforms needs to be all together. One service, boom. You don't need to know about that. You don't have any difficulties from anywhere. Big data can be delivered to you. That is Netflix. A lot more than YouTube. YouTube is still good, right? Very handy. We don't have any difficulties.
Is it a lot more than YouTube?
Technically, yeah, technically, because they are dealing with the bigger size resources. Netflix. Netflix is, Google is small video clips, right? Usually. This class will be on Google, YouTube.
I never use Netflix. I'm always on YouTube. But I
Netflix is like movies.
Yeah, movies, dramas, and everything.
Yeah.
I never personally use the Netflix.
Try to use.
Sure.
You can't skip around the video as fast on Netflix compared to a YouTube video. A YouTube you can jump around the video and it loads very quickly. And I don't know if it's just the sheer size of the data, like a movie versus a 10-minute video, right? did notice that. Like with Netflix, I don't like to skip around because you can't. It doesn't load as fast as skipping around a YouTube video. I think.
Oh, that is that's the weak points of Netflix.
Yeah. I mean, I don't have any quantitative, measurements. I just
Okay,
think
okay.
that's what I observe.
Yeah, sometimes you have to wait.
Right.
Yeah.
Same with
Okay.
Hulu or any other. I have more than one streaming service.
Okay. Yeah. So there's a new trend, basically. If you know all technical features of what's going on behind that big services, then you are on the leading edge of the new technologies. Netflix. So example of those, I listed a few of those. Netflix, Google Search, Amazon. Look at the Amazon's orderings. Huge, right? But you can see yours very quick. If you want to chase tracking your deliveries, how many request trackings simultaneously? Because millions of people are currently using Amazons. But when I track my order, I can see my order very quickly, right? So technically, something really advanced behind. So why don't we find out something behind? Uber, Facebook, more and more, right? So I listed some of those. So Netflix leverages a microservice architecture where different services handle specific functions like user authentications, content recommendations, and video streamings, so on and so forth, right? Deployment. Netflix operates on a global scale using a vast network of data centers. How many data centers they are running? Hundreds data centers they are running. They all know each other. Content Delivery Network, CDNs, to serve content to millions of users worldwide. It also utilizes Amazon Web Services. So Netflix is another way that is a client to Amazon. Amazon is tech company somehow. Like Tesla is AI company, right? It's not just the automobile companies. That's what we can emulate. What Tesla software maintained, we can maintain. We may know something from this class, how we can do. Some of the modules that you run on your Raspberry Pi can be handled by your Google Cloud. Okay, some data may be shared from your Google Cloud. Therefore, your Raspberry Pi is not just running single standalone behavior, but it is somehow related with the cloud services. So Netflix, and Google Search, everybody uses Google Search, right? I've used Google Search a lot, now half and half between OpenAI, not OpenAI, ChatGPT. We're going to use OpenAI. Some of the classes I'm teaching OpenAI, but maybe we can include OpenAI here. Then you need to subscribe to OpenAI. Unfortunately, anything that is handled by Microsoft, then they charge. That is something that I hesitate you guys need to do with the OpenAI right now. For this, yeah, probably not. But some of the class that I am teaching for cybersecurity, I am asking you just to use OpenAI, because this class, you guys subscribing so many other things. So when you do your Python code, then you can When you do code, then you can do not only some of the capabilities that you develop on your own, but your code indeed will be able to collaborate with whatever the outcome from OpenAI. So anyway, Google Search. Google Search relies on a complex network of distributed systems that index, query, and retrieve information from the web. We all know that, right? Google operates numerous data centers around the world, each capable of processing large volumes of search queries. If you want to serve at the fast speed, then all the searchable materials needs to be available. If you want to access from your storage, then you client will not wait for that. Right? Client wait only 2-3 seconds. If your Google server needs to access their storages, it takes longer than that. What that means is that Google therefore make all the content available on that memory, huge memories, right? So memory access still needs take time. So what they do now, not only rely on CPU but GPU, right? You guys use GPUs, right? A lot. So data science majors, right? How can you use GPU if you do not have enough GPU on your laptop? My laptop doesn't have GPU. Anybody has a laptop with the GPUs? Did you buy GPU? Probably not, right? In order to do that, then you need to use Google Colab. If you use Google Colab, then you can set up GPU. If you want to use bigger size of GPU, then they charge you. Google is generous a little bit. So if we use small volumes, they don't charge. Unlikely Microsoft. Microsoft, they charge you any tiny bit of resources of Microsoft. So Google, that is Google. Amazon. We all know Amazon. E-commerce platform built on a distributed architecture that supports millions of customers, vendors, and products. This is one of the things that Amazon architecture uniquely different from Netflix and Google Search. So there are so many different players. Client who wants to purchase has different content. Clients who wants to sell, so-called the vendor. Vendor has different content. They're all subscribe to Amazon. Therefore, Amazon is somehow a platform to link them, right? Billing them. Who collect money? Amazon is collect money, right? Where there is money, there is the king. So Amazon is the king, right? Although there are so many buyers, so many vendors, money goes to where? Amazon first, right? So Amazon collect the money first, and then vendor later say, hey, give me my money. Then Amazon give money back to the vendor. Clients, when the client wants to buy, then Amazon says, pay first. Unless you pay, we cannot deliver anything. So collect the money first and pay back to the vendor later. How many days? I do not know. But at least it is not simultaneously. How many vendors and how many customers? So many, right? Then how much money? Really, really big money. So Amazon always holds big money, although it is not their money, right? Technically it's not their money, but they have their money continually. Then who is the king? Amazon, right? That type of business is really, really good business models. I want you to think of that. You guys can develop something like that. Very similar to Amazon is the Uber, right? Customers pay first. Uber drivers receive the money. I do not know how fast, but not simultaneously, right? So company-wise, they hold big money all the time. Technically, that big money is not their money at all. See, if I have big money with me, although that is not my money, but all the time that big money is on my pocket, why not? That is my money, right? I have money power. If I pay back, still I have money comes in to my pockets. So all the time, 24/7, that money is on my hand. That is a Google, that is an Amazon business, that is a Uber business. Technically, what technologies sits behind? Microservices architecture. Microservices architecture. That's what we want to practice. So Uber, similar, Facebook, more. Topics that we want to consider in this class. Okay, I listed them there. Many of those will be discussed deeper and deeper. Some of those shallow. Distributed computing models, that comes next week. Cloud computing, when it comes to cloud computing, then we need to set up cloud server. Each one of you will have your own cloud server. If you want to start your business, you can use that cloud server. If you have a bigger clients, there is a time that you need to pay to Google. Until that point, they don't charge you. Distributed database, distributed file systems. Not only database, but we are going to look at the file systems as well. Because file systems is still, it's not technically secure, but still widely used. Netflix, for example, Netflix movie or Google, YouTube video clips, they're all file. They are not in the database. So file system is, we cannot avoid file systems. Decades ago, many computer scientists wants to keep any media, anything they want, any digital assets. As far as there is digital assets, they want to keep that digital assets on database. That was a big project. When was that? I think at least 20 years ago. So Berkeley and Stanford computer science professors try to build that. But so for example, Oracle wants to keep all the operating systems within their Oracle databases. Why? Because database is much more secure, much formal, and well maintained. So why not keep all the operating systems within their databases? So database is a big umbrella. Within that, operating systems within that, something and something. Was it realistic? No. Was it realized? It didn't, right? What does that mean is the file system is important. While we know there's a formal and very secure and well-formed architecture, that is on database available. Middleware, we'll look at that middleware. Service discovery, load balancing, fault tolerance and reliability, security in distributed systems, distributed caching, distributed consensus, event-driven architecture, microservices communications, monitoring and observabilities, service list computing. Those are the concepts that we're going to consider. Okay, getting ready. Software modules for the platforms. We're going to use 3 devices: cloud server, Raspberry Pi, and laptop. Each one of you already have laptop. Some runs on Windows, some Mac OS, some Linux, whichever will be okay. Cloud server, we're going to subscribing to Google Cloud Virtual Machine. And then we will build Apache, there's a web service. PHP, that'll be the language that we're going to build the middleware. MySQL, your content needs to be stays on that MySQL. Raspberry Pi, so MySQL is a database server. On the other hand, we have a Raspberry Pi 5, which holds file server. Okay, the language that can run on Raspberry Pi is Python. Laptop will be the client. That client needs to connect Raspberry Pi and cloud server. Okay, so Python is the language on your laptop.
So I do see here that you want us, and you mentioned that you want us to purchase the free installation of Google Cloud, set an account of Google Cloud. But for the Raspberry Pi, do you provide us with one, or should we buy one?
We will provide you one to each students. Yes.
So I have a similar question. So if the college is going to provide us with this toolkit for all of us, do we have to apply for it, or do we have to sign up for it? Or?
I'm going to link you guys to the department secretary, and department secretary knows where this kit's available. There's in my office, so I'll ask her to give you if you access the secretary. If you cannot go to Dobbsbury campus, then you need to talk, whichever convenient. You can ask her to ship this kit, mail services.
I have some of my toolkit from my last semester, so will this work, or I have to rely on?
This is a brand new, a lot more faster.
Okay.
Last semester that I asked you to purchase on your own, there's a cheap ones. This is a Raspberry Pi 5 new models.
Nice.
Yeah, very, very powerful. Big advancement. Yeah. Okay.
Do you think we can run a Raspberry Pi virtual machine on VirtualBox and still be able to follow along with the class content?
Yeah, I'll guide you all details. You don't. What do you mean by virtual?
I
box
mean,
of
like instead of a physical Raspberry Pi that I would connect to my computer.
physical?
I would, yeah, I would.
No, not connect. Raspberry Pi does not connect to your laptop.
Oh, okay.
Raspberry Pi connect to your laptop through the router.
Yeah.
So there's a reason this classroom, so we cannot work continually because we do not have a router in these classrooms. We set up the local router on the 425. I explained that on your syllabus. Did you read that?
Yeah.
So there we have a router. We can do it, but that classroom was not assigned to us. What that means is that we cannot do continually in these classrooms. Therefore, we may go back home. You can go back home. I also go back home. because your home, you have your own router, right? So your router does allow to communicate from your Raspberry Pi to your laptop, vice versa. Here, no. Okay. All details, not right now. Until we set up cloud server. Cloud server is the third module according to our schedules. So at least first 3 weeks we come here. After that, depending upon the topic, at certain point then we need to go back home. Okay. Still, you need to come to the Blackboard, where you may be able to see my lecture notes, my recordings, all of my homework assignments. So homework assignments continually assigned to you. Okay, so if you guys want to get special help, technical help, then we can set up Zoom. Only the problem with the Zoom is Zoom, we can see, yeah, Zoom may be okay, right? I can turn on camera, right? So you can see me. So platform, we need to set up Google Cloud, Raspberry Pi, laptop. Software, as I listed, those. Developments, database, PHP, FTP server, that should be, I'll give you the code, so you may run that on your Raspberry Pi. Then your Raspberry Pi will be a server. Your laptop will be a client. Your laptop can be a server also if you have the MacBook. Windows, you cannot. But anyway, you have cloud server. So our module here, laptop is a client, Raspberry Pi and cloud server. Those are the servers. File management, database management, query processing. Pedagogy of this class. Understand the concept first. And then we have to practice. I can make millions of the slides about distributed application developments. You may sit down and read. But if you do not practice it, there will be nothing, right? One day after this semester ends, there's no gain. So practice is really, really important. So we're going to do that. Any single practice that you do on your own hands, then that'll be your skill, okay? If you watch my recordings only, then that is my skill. It's not your skill. That is the reason I ask you to do homeworks. So everything that I do on my recordings, you have to redo at your side on your own. That'll be your homeworks. Practice. Okay. This class will use the Python. Python, you guys have a Google Colab or Paizo IDE. Rather than Google Colab right now, I want you to set up Paizo IDE. Paizo IDE can be downloaded from that www.paizo.org. Let's try to see that. Then if you go somewhere here, then www.paizo.com. Is it paizo.com? Org, sorry. Do not type com. Paizo.org. There's a quick start. Click on that quick start. Then install Paizo IDE. Windows user, Mac user, Linux users. Okay, so you download two things that you have to download: Paizo and Python. Okay, this is Paizo. And Python needs to be downloaded also. Oh, I didn't. Okay. So this is a Python, either this or that. You install it, then application, you can put that on here, Python, or Python that I have here. Python, click on that. Initially you have nothing here, something like this. And then you have to download the Python, python.org. Then depending upon your platform, you can download it, Python. So I want you to download the recent version. Download. Because Python knows which platform that I have. You already know Mac OS. So you need to download the 3.12.5. This is the recent ones. And you install Python and Python separately. So download it separately, install separately, and stop there. And then you open up Python. Okay. Then there's on shell side. Look at my mouse. Shell side, there is one small icon. Click on that. Then two menus available, right? Edit shell configuration and new shell. If you see my new shell, then I have already 5 the shells available. That's what I installed, right? This is recently I installed. I think I installed it yesterday. This is a Python 3.12. This is a recent versions. How can you install it? Okay. Python you installed already. Python you installed separately. The next step is that you have to open up Python and come here Python. First thing that you have to do is edit shell configuration. So let me show this. Click on the edit shell configuration. There are 5 tabs. Each tab for different version. On the right end, on top, there's add config. Okay, add config. If you click that add config, then you can say, you can say test. Then this will be the name of that shell, your new shell. And then once you install Python, exe will be automatically picked up. These are the 5 versions, 6, yeah. Those are versions of Python that I installed on my laptop. So you need to choose that you installed. My case, I installed the 3.12.5. This is the most recent version that I installed yesterday. You need to click that. Then your Python is communicate with that Python. And then you can say done. And then come back here again to the same icon, new shell. Then you see here test that I named the test for that. So if I click that test, then it picked up the version of Python 3.12.5. This is the most recent versions. That version was released August 7, 2024. From there, you can do Python. So your first homework assignments of Python is in this way. I'll guide you a little bit. So you can do names is a list. I ask you to do, your name may be John Yoon in this way, or your name may be Yoon, comma, John, or your name may be full name. Those are the names that you can say, right? Your first homework assignments, if you use John Yoon, then you will get 0 credit. There's credit for John Yun. You need to use your own name. Okay. And then for loop for each in names, and then we can print each. This guy way. Okay. And then here you can save Control S or Command Control S or Command S, and find out where you want to save. So I have here 545, and then I will make a new folder in class, and then I'll save it, homework 1. Look at here, this is a .py, so you do not have to worry about. This is a .py. Save this. Don't be frustrated, even if you cannot follow, because I'm go the right speed. This will be recorded, so you can revisit. If you go to my class 545 here, and then in class, then I have here homework1.py. That is this file. Okay, homework1.py. Save it. If you want to run this, then simply Control return or Command return. Then it returns each element in the list will be displayed. John Yun, Yun, John, Jongpil, Yun. But this is not what I ask you to do. What I ask you to do, depending upon whichever it comes in this list, I want you to say, my name is John Yun only, like this. My name is John Yun. First one is okay, but the second and third one is not okay, right? So you need to do a little bit of massaging. If something, right? For example, you need to make a size, length of names. Oh no, you don't need to do that here. Yeah, size equals length of each, and then print size, and then I'm able to see, oh, this is not good, right? We need to do length of split. Then what is the length? John, if you do John Yun, that length 2 words. Yun, comma, John, that is 2 words. John, Jongpil Yun. So this is a full name, right? First name, middle name, and last name. Then that is 3 letters. So depending upon this, we can do, say here, if size equals 2, and then also here, if size equals 1, if size equals less than 2, then you can do print. And then we can do Let's see what happens. My name is John Yu, and my name is John Yun. So far, so good. Yeah, my name is John Yu, my name is John Yu. We handled this too, right? I didn't handle this. I want you to do that. This is a sample. Oh, sometimes it comes. All right. So you have to submit this homework1.py on that blackboard. This is simply I am trying to test to you how much that you can handle Python code. Okay, I gave you a simple way that you could do, but you can add more capability to do that. This is basically what we will do throughout this class when I give you homework assignments. Sometimes I give you full if it is really difficult to. So as far as you follow my lecture notes and the video recordings, you'll be okay. Some of the things like this relatively easier, then I will stop at some points and you can finish it up. Clear? This is all that I prepared for the first class. I know I left a lot of things onto you so that you can finish it up. This is the problem that I didn't expect. This is another problem.
You can't even test because you plug into a wall, right? There could be an issue with that adapter and the TV.
This is what IT guys came here to help
Yeah.
today. He said if I plug this directly, then more problem. He didn't expect this problem, but he said there'll be a problem if I plug this.
Yeah.
Anyway, let's do that. This is the problem, so let's plug directly. So some instructor came here and touched a little bit of those and it messed up.
And you plug into, yeah.
He said this is the way that we do.
I just usually use the mainly, so I want to keep it all in one place. And it's not the best for Python, but
That's gone.
do you control it with a remote, like a TV remote?
I'll stop recording.